Hey everyone, we are about to do our last lesson before the STAR test. And we are in Unit 8, which is titled Solving Quadratic Equations. We have learned two ways to solve quadratic equations so far, and they are factoring and the quadratic formula. That would be lessons 8.1 and 8.3. Okay. The last method is simply graphing. Because if you recall, when you're solving, what are you solving for? What are we solving for? When we are solving for these solutions. Let's think of what another word is for solutions. Pause a moment and think about what those words are. Hopefully you thought of something like zeros or roots or x-intercepts. All of those things mean the same thing. So when we are solving, what we're really finding is where does the graph touch the x-axis? So do we have to use factoring and the quadratic formula? No, we could just graph it and see where the x-intercepts are. Now I do warn you, on the test, that will be Thursday, we do need to check and see on there are two questions. One where you are required to factor, I'm going to write that down. One question that you will be required to factor and show work. One question where you will be required to use the quadratic formula and show your work. And then there will be 6 questions where you can use any method. It doesn't have to be graphing. You could use factoring. So I'm going to actually erase that real quick. To be clear, you don't have to use factoring. You can use any method for the remaining 6 questions, any method you want. If you want to use the quadratic formula or factoring or graphing, it is up to you. But 2 of them, one has to be factoring and one has to be the quadratic formula. So keep that in mind. All right, so let's move into the actual lesson. Remember, the goal is to solve by graphing today and finding the roots, otherwise known as the x-intercepts. Okay, so our learning target is I can solve quadratic equations by graphing. We want to make sure that our equation is mostly in standard form and that it's all on one side. So let's go ahead and write that on here. The other words for solutions that we had on there, remember? One of them was roots. So they're called solutions. That word is already listed. They're called roots, zeros, x-intercepts. Most of the time, quadratic graphs have 2 x-intercepts, but like you can see here, one of the x-intercepts is just -3. This one only has 1 x-intercept. It only touches the x-axis 1 time. Most of the time you will have 2, but occasionally you might have 1. Or it may not touch the x-axis at all. That's always a possibility. Okay, so let's use Desmos now a little bit. So go ahead and open up your booklet and look at the first example. So the key is here that when you are graphing it in Desmos, to not put the =0 part, okay? Don't put this in your calculator. I'm going to write it on here. Don't put =0 in the calculator. You may want to write that down as well. So I'd like you to give it a try right now. Go ahead and type in 3x squared minus 30x minus 72 in your Desmos calculator and see if you can find the x-intercepts. Okay, I have mine graphed and I can see that it is descending and then it'll come back up and you can see here the x-intercepts. If you want to know exactly what they are, make sure that you actually click on the equation so that there's a cursor blinking. And then look, these 2 gray dots pop up where you can hover over them and see the x-intercepts. So our x-intercepts are -2 and 12. Okay. So what are the solutions, otherwise known as x-intercepts? You may want to write that on there so you don't forget. Solutions really mean x-intercepts. One of them was -2. And I'm going to write both of them in brackets and list them. One of them was -2, and then the other one, let's double check. The other one was 12. Those are the two solutions. And the question asks, which value of x is a solution? There are two. It is not -12, it's +12. Definitely not that one or that one. -2 is the only solution that is listed. So all we did was graph it, guys. Just don't forget, don't put the equals 0, okay? So now let's go to example 2. Very similar, except that we have to get 0 on the right side first. So you need to move this over to the left. Now, generally, I move it and I point the arrow where it's going to go, because as you know, the x squared, which is 2x squared, should go first. And then the x comes second, which is this -11x. But when you move it over, it becomes +11x. Keep that in mind. And then the constant, the +15, is still there. And now that that 11x has moved over, there is nothing left on this side. Now here's the part that you type in the calculator. So go ahead and type it in and find your roots or solutions. Remember, another word for solutions is root. Okay, or roots. What are the roots? Pause and try and find them. All right, guys, so on this one, I did have to zoom in a little bit. You can use your mouse pad to zoom in or out, or use the plus or minus over here. And you can like drag to move left or right. Remember, click on the equation so you can see the dots. One root is -3, and the other is -2.5. So -3 and -2.5, that would be answer choice D. Just remember, roots and solutions and x-intercepts, they are all the same meaning, okay? And the brackets, guys, remember, this is not a point, this is just a list of your x-intercepts in the brackets. All right, let's look at this one. Now this one is interesting because it's not in standard form ax squared plus bx plus c. It's a little more similar to vertex form. So if you recall, vertex form is ax minus h squared plus k, and we can add an equals 0 onto it. So we want it to look like this. So right now the x plus 7 squared is there, but the 81 is on the other side of the equal sign. So we're going to do what we did in the last problem, and we're going to move it over to the end and make it negative. Remember, when it moves sides, the sign changes. So x plus 7 is still there, but now you have a minus 81, and then there's nothing left on the right side. You don't have to convert this into standard form. You can type it into the calculator just like you see it. Just remember, don't put the equals 0. So take a moment, the part I have highlighted, please type it into Desmos and find the solutions. Okay, guys, I have typed it in, noticing that I did not put the equals 0. That was there, guys. And I did have to zoom out a little bit. You may have to zoom in and out and move the graph around a little bit to get what you want. But always click back on the equation so that the vertices show themselves to you. Sorry, not vertices, x-intercepts. One of them is at -16, and the other is at +2. -16 and +2. They will try to trip you up because it's clearly not F or H, but they might give you one like answer choice G, where the signs are opposite. Okay, so make sure to watch out for that. So all three of those were equations that we needed to graph to find the solutions, otherwise known as x-intercepts, zeros, or roots. So let's look at the other examples that we have. We have 3 more, and they're all a little bit different, but they all mean the same thing. Now in this problem here, yes, you could factor it. Okay, you know, make your eye chart, identify A, B, and C, create your eye chart there. So here's standard form. You could factor it to look like this or this. You know, I don't know which one's the correct answer, but it is easier to see the right answer if we just looked at the zeros instead. Look at the front of the answer choices, zeros. Zeros, remember, is just another word for x-intercepts. So type in the original equation and then go ahead and find those x-intercepts and see what they are, okay? So let's go ahead and pause the video and give it a try. Okay, so please note on this particular problem, there is only one x-intercept. It touches the x-axis only one time. So seeing that, if I go back to my problem, there's only one on here that says there's only one solution. You can see that this one has two solutions. This one has two solutions. This one actually also has two solutions because this is saying positive 9/2 and negative 9/2. Whereas this one, the last one, D, only has one solution, so it must be my answer, 9/2. Okay. On the calculator, keep in mind that when it shows you it, it shows you the decimal. 9/2 is 4.5. Okay. So that was the answer to number 4. It was D because it's the only one that had only one solution. The rest had multiple solutions, multiple x-intercepts. All right, this one is even curiouser. Okay, let's read through it. The area of a rectangular trampoline is 112 feet squared. The length of the trampoline is 6 feet greater than the width of the trampoline. This situation can be represented by the equation below. What is the width of the trampoline? So the width is the x, right? Because normally we use x's and this one's using w's. So really width means x. Now keep in mind on Desmos, everything has to be x's. You cannot have w's. Okay, so let's rewrite it. X squared plus 6x minus 112. Don't even put the equals 0 because remember you can't type it in the calculator anyway. Now go ahead and type that in and find your x-intercepts. Okay, we can see on here we do have two x-intercepts or solutions. One is negative 14 and one is positive 8. So let's write those down. X equals 14 and, negative 14 and x equals 8. I'm going to double check that to make sure I'm correct. Yep, negative 14, positive 8. Now there are only 4 answers on here. And I see 14 and I see 8. The biggest issue we have here is that you cannot have, remember what this actually stands for. The X actually stands for the width, and you can't have a negative width. So this is not the correct answer. The answer is 8. So when you're doing a real world problem, you really need to think about what makes sense. We can't have a negative width or height or a negative amount of time. So keep that in mind when you're looking at real world problems. Okay, even though we did have two x-intercepts, only one of them was the correct answer. So take a moment and look at answer number 6, read through it, and then go ahead and graph that equation. Just remember, change all of the n's to x's. Okay, so in this case, let's have a look. We've got an equation, p of x equals 52x minus 0.05x squared. Hopefully you changed all the n's to x's and then graphed it. We want to find out what happens when n, or in this case x, is 400 pies. So we want to know how much profit they're going to make. So in here, we're going to type in x equals 400. And so let's see where they intersect. I had to zoom out a lot because they made a lot of profit. So I want to find where they intersect. So once again, click on the equation so you can see where they meet. So at 400 pies, they earned $12,800 profit. Take a moment to write that down. Okay, so in the second part of the question, it's giving you the profit and wants to know how many pies. So if x is the number of pies, then y must be the profit. So let's type in an equation, y equals 13,520. So you can see here that this is the maximum height and the maximum profit they made was 13,520 pies. Okay, once again, you can see I typed in y equals 13,520 and got the number of pi's.